For this lesson, we are going to look at writing algebraic expressions. So we've already worked with numerical and algebraic expressions, but now we're going to write our own. So some reminders of some important terms for this. A variable is a letter used to represent an unknown value. And an algebraic expression is a number sentence without an equal sign that contains at least one variable and one operation. This is an algebraic expression because it has a variable and it has the operation of subtraction. This has the variables and it has addition. This is a algebraic expression because even though we can't see the operation, when you have a number written right next to a variable, that means multiplication. So what we are trying to do as we write these algebraic expressions is, first off, we want to get away from using x for multiplication. So as you can kind of see here, if I was trying to show 3 times x, it would be really confusing if I used x for multiplication. Which one's my variable? Which one's the multiplication? So we don't want to use it. There's 3 ways that you can show multiplication. You can use a dot, that means 3 times x. You can use parentheses, that means 3 times x. Or you could write the number right next to the variable. 3 times x is what that means here. This is the way that we want you to get in the habit of writing. This is the most common, the most, the clearest way to write it because it's right next to each other. We don't have any extra parentheses or dots or anything. The other thing we try to get away from using is the division sign. Instead of the division sign, we use a fraction bar. So number 1, the quotient of a number and 7. We filled out this sheet, but you also have this in your resource packet. It is after the order of operations, it's after converting between fractions, all that stuff. So write an expressions cheat sheet. We can use this to help us remember what terms or what words mean the different operations. So remember, when we've got a problem, the first thing that we do is we circle our numbers, and then we're going to highlight the important words or key terms, which is quotient, and we underline the unknown. So in this case, our unknown is the number. We could use n equals a number. I'll use it for this one. You could use x because x is the most common one to use. And sometimes you can use different variables as long as it pertains to the problem, but don't just pick a random one that doesn't make sense. So we've figured out our unknown. We have the quotient. So if I look on here, I see that quotient is a division word. So quotient is a division word. I'm going to write the division symbol underneath it because I know I have to divide. Some people would write this and say, okay, the quotient of n divided by 7. We're not going to be as harsh with this one, but as I said, we kind of want to get away from using the division sign. So instead, we use the fraction bar, which you can see on here. When it was the quotient of a number in 13, we did x over 13. So same thing, the quotient of a number in 7, we're going to do n over 7. Number 2, 10 less than a number. So again, I circle the numbers. I'm going to highlight the key terms, key words, and underline our unknown. So again, our unknown is a number. Maybe this time I'm going to use x. X equals a number. Less than. I need to look at my chart. I see that less than is a subtraction word. And again, this is helpful because it gives us the examples there. So I know this is going to be a subtraction problem. But I want you to put a star next to this. This is the type of problem that most people get mixed up on and make mistakes on. I'm saying it now and you're going to be like, no, Miss Krippinger, no way, I'm not going to make mistakes. It's probably one you'll make a mistake on. So what is important is that whenever we see this then, less than means it comes after. If I said you are 10 years younger than me, you're not going to do 10 minus my age. You're going to take my age minus 10. So what I do with these problems, whenever I say the then, less than, I'm going to write the minus 10 right away. It's 10 less than. I'm subtracting 10 from something. What am I subtracting it from? I'm subtracting it from my unknown number. And again, if you use this, you'll see we have our example, 3 less than a number, x minus 3. More often than not, your variable's on the left. Number 3. 3 times the number of gallons. So, circling my numbers, highlighting the key words here, which I see times, and underlining our unknown. This time, it's a real life scenario, the number of gallons. So I could keep using X if I wanted to, or maybe I'm going to use G to represent the gallons, so number of gallons. If I'm looking at my chart, I see that times represents multiplication. So it's 3 times the number of gallons. Again, we want to get away from using X for multiplication. We have these 3 different ways to show it. The best way is to write it right next to the variable. So 3 times the number of gallons is just going to be 3G. That means 3 times G. Number 4. Let's do 8 more than a number. So circling our numbers, highlighting the keywords more than, underlining our unknown. So again, we're back to a number is what's unknown. I'm just going to say X equals a number. More than, if I'm looking at my chart, I see that more than is an addition word. You have more. If you give me more money, that's good. I'm adding value to my account. Technically, addition, if we think of the properties, the order doesn't matter. 2 plus 3 is the same as 3 plus 2. So really, either or could be accepted here. But just like with less than, anytime I see then, less than, more than, greater than, younger than, anytime I see that, it comes after. So if I see 8 more than, right away, just like I did with subtraction, I'm just going to do plus 8. What am I adding 8 to? 8 more than the unknown number. So technically, for addition, you could do it the other way, but if you just get in the habit of writing it this way, it's going to make it less likely that you'll make a mistake with the subtraction ones. Number 5, John is 9 years younger than Colin. So circling our numbers here, highlighting those key terms. So younger than, and our unknown. We're trying to figure out John's age, but we're relating it to Colin. We don't know Colin's age. So again, real world scenario here, you could use X, or I'm going to use C. C equals Colin's age. So younger than, if I'm looking on here, I see that younger than is in our subtraction category. So younger than is a subtraction word. Again, be careful with subtraction. Whenever we see less than, more than, younger than, it comes after. So 9 years younger than, right away, I'm writing that I'm subtracting 9. What am I subtracting it from? It's 9 years younger than Colin. So our unknown Colin's age. All right, now we're gonna look at two examples where we write and evaluate. So we've already done evaluating algebraic expressions. We're just combining these two things. So example 6, a plumber charges $60 per hour worked. So I'm circling my numbers, $60. And then we don't know, or our key terms. This one's a little bit harder, but if I look on my chart here, I'll see the word per, and we have that as a multiplication word. So I see per hour, which is telling me it's $60 times however many hours. We don't know how many hours are worked, so that's what I'm going to underline. That's my variable. Since it's a real world scenario, I'm just going to use H. So H equals the number of hours. So now writing an expression. We know our number is 60. We know we are multiplying times our unknown of H. When we use multiplication, it's best to write it right next to each other. So if we're doing 60 times the number of hours, 60H. Now part C is the new part. Now we're going to take this expression here. So we're taking this expression and we're going to plug in 5 hours for our unknown. So we are saying it's 60 times the unknown value of 5, or our unknown value of H, which we're saying, well, what if H, the number of hours, is 5? So if you can do that in your head, great. If not, use a calculator. 60 times 5 is 300. And we were talking about find the total cost, so it's $300. All right, number 7, last one. Alvaro has $682 more than Michael. Circling our numbers, highlighting the key terms. I see more than. And our unknown, it's more than Michael, but we don't know what Michael has. So M equals the amount of money, because that's what we're talking about, Michael has. And then more than, if we're looking at our chart, we see that more than is an addition word. So I'm putting right here that we are adding. Remember, anytime we see more than, greater than, less than, younger than, it goes after. So 682 more than means I'm adding 682 to something. What am I adding it to? I'm adding it to whatever Michael has, because Alvaro has Michael's amount plus another $682. Now for part C, we are taking this expression that we just wrote and we're going to plug in this value. So find the total amount of money that Alvaro has if Michael has $555. So we're taking that expression, M plus that 500, sorry, wrote that wrong. Our unknown, M, is $555. That's what Michael has. Plus the 682. So we plugged in this 555 where the M is. And then I'm just going to plug that into my calculator. And I get, I'm going to do it here because my calculator is not right next to me. 2 plus 5 is 7. 8 plus 5 is 13. 1 plus 6 is 7 plus 5 is 12. So I get $1,237.